Hi, welcome to Mathematics with Tom. I am Tom, and today we are going to solve y triple prime equals 2 using the Laplace transform. Our first step is going to be to transform y triple prime equals 2. And in order to do that, we're going to use some work that we just learned. We just learned that the Laplace transform of y triple prime is equal, and I'm going to give us, you know what? Oh yeah, we'll do it this way. For just some initial conditions. And we said the Laplace transform of y triple prime is equal to s cubed y of s minus s squared y of 0 minus sy prime of 0 minus y double prime of 0. And that's it. So if I just apply the Laplace transform to y triple prime and the Laplace transform to 2, let's see what we get. On the left hand side I have s, and I'll just write that again. I have s cubed y of s minus s squared y of 0 minus sy prime of 0 minus y double prime of 0. And this equals, remember the Laplace transform of 2, well, that's really just 2 times the Laplace transform of 1. But that, remember, that's just 2 times the Laplace transform of e to the 0, or e to the 0 t. And remember, that's just the Laplace of e is 1 over s minus a. In this case, a is 0. This becomes 2 over s. Okay, now the next thing is we want to solve for y of s. I'm going to do it in 2 steps. The first step is I'm going to move all of my initial conditions to the right-hand side. So I have s cubed, capital Y of s, is equal to s squared y of 0 plus sy prime of 0 plus y double prime of 0 plus 2 over s. Well, now let's solve for y of s. So y of s equals, now I'm going to divide every term by s cubed. So, but notice that the y of 0, this is going to become a y of 0 over s. Plus, this next term, an s will cancel, so I have y prime of 0 over s squared. Plus, now this one's going to become y double prime of 0 over s cubed plus 2 over s to the 4th power. And that's the transformation of this differential equation. So the next thing is to find the inverse Laplace of y of s. Okay, so we apply the inverse Laplace transform to both sides. So before we do that, I want to just write these in a way that might look a little bit more familiar to us. Let's write this as y of s is equal to y of 0 over s minus 0 plus y prime of 0 over s minus 0 squared plus, then we had a y double prime of 0. Remember, those are just numbers, divided by s minus 0 cubed plus, I'm going to write it this way, plus I have 2 times 1 over s minus 0 to the 4th power. Okay, and remember this. We said that the Laplace transform of t e to the a t is equal to 1 over s minus 0 squared. And we also said that the Laplace transform of t squared e to the a t is, oops, that was an a, not 0, 1 over, no, it's not. This one became 2 over s minus a cubed. And finally, the Laplace transform of t cubed, e to the at, well, this was equal to 6 over s minus a to the 4th power. And it's those that we're going to need to use. So when we write y of t, we're going to take, I'm going to write it out one more time so you see the steps. So we're going to take it, we'll write it this way. The inverse Laplace of y of s equals y of 0 times the inverse Laplace of 1 over s minus 0 plus y prime of 0 inverse Laplace of 1 over s minus 0 squared plus y double prime of 0 inverse Laplace of 1 over s minus 0 cubed, and I'm running short on space here, plus 2 times the inverse Laplace of 1 over s minus 0 to the 4th power. We're almost done. What we need to do, though, is notice the first few terms work out really well. So we have y of t, the inverse Laplace of 1 over s minus 0, this is y of 0, e to the 0t, but that's just 1, plus, I'll write that, e to the 0t, plus y prime of 0, the inverse Laplace of 1 over s minus 0 squared, that's referencing this problem right here. Oh, that came out really thick. That's just this. So we can write this as t e to the 0t plus, now we have a y prime of 0, and we're going to use our the next inverse or Laplace transform that we found. So let's do that. That's going to give me a t squared e to the 0t. Oops, that was a y double prime of 0. Plus, now here's where it gets interesting because I need another color. In order for this to work, notice that what has to happen is I need a 6 in the numerator. I need a 6 in the numerator, but I don't have one. So what I'm going to do is multiply by 6 and multiply by 1/6. And remember, the Laplace and the inverse Laplace are both linear operators, and so we can move a number in and out of the transform. It's just the s that has to stay inside. So there we have it. So this is really 1/3 times t cubed e to the 0t. And I got the 1/3 from 2 times 1/6. And we can clean up our answer really nicely now. Our final answer is y of t is equal to y of 0 plus y prime of 0 times t plus y double prime of 0t squared plus 1/3 t cubed. There it is. And that is how the Laplace transform deals with resonance. I hope that helps, and thanks for watching.